Okay, I just want to quickly just go over some of the things we talked about today and just show it to you in a couple of different formats. So, just to give an example of questions, for example, if I had, x plus 3 equals 7, right? Couple ways we can look at it. The one that I think is more intuitive for you guys is just looking at, whether it would be tiles or counters or whatever. If over on this side I had 1, 2, 3, 4, 5, 6, 7, and on this side I had 1, 2, 3, the x represents an unknown amount. Well, you can visually see that, okay, I've got 3 here, so here's 3 here, I've got 3 here, so to match things up, I know that I have to have 4 here. So that way you know x, or the unknown number, that equals 4. Another way you can look at it is what we talked about, where if we look at the number line. So once again, I'll just draw it again, or write it again. If x plus 3 is equal to 7, right? 7 equals, right? Equal means things are balanced, right? And I know that when I perform this operation, my endpoint is going to be 7. So if I'm on a number line, start with 0, 1, 2, 7. This is where I finish. So, if I have to add 3 to a number that I don't know to get to 7, well, if I start at 7 and go back 1, 2, 3, I'll know where I started, and that means that my starting place is 4. So once again, I know that my x, or my unknown value, is 4. Now another way you can do it is with balancing equations. Same idea. If I have x plus 3 equals 7, big thing again is that equal means balance. So everything on this side is the same value as what's on this side. So if I don't want to know what x is, I need to actually just get x by itself. And right now, x has a plus 3 on this side. So what I want to do is I need to remove that plus 3. And to do that, well, I just do the opposite. So if I have plus 3, the opposite process of plus 3 would be minus 3. So x plus 3 minus 3. And this goes back to the equal sign. Equal sign means that everything of this value here is the same as value there. So if I take away 3 here, I also have to take away 3 here. So we go down to the next line. I have x. If I add 3 and take 3 away, I'm left with 0, so I don't have to write anything. And if I have 7 minus 3, it is 4. So once again, for all 3 of the methods, we've used different ways to come up with the same type of value. Now the only thing you can do at the end to make sure is you can do what's actually called a proof. And to prove anything, all I need to do is sub in my x value. So I've said here that x equals 4. So up here I'm going to put in a value of 4. 4 plus 3 equals 7. Well, 4 plus 3 does equal 7, so that means it's true, and that means you balance it properly. So tomorrow in class, you're going to be developing equations, and then you're going to solve them. And when you're looking at solving those equations, these are the types of methods you may want to try. Now you can also try methods of your own, as long as you're able to solve and to prove what you've done. That'll all work.